So today we are going to talk about relaxation oscillator. So this was my topic, relaxation oscillator. So what is a relaxation oscillator? A relaxation oscillator is defined as a non-linear electronic oscillator circuit that can generate a non-sinusoidal repetitive output signal. A relaxation oscillator. A relaxation oscillator was invented by Henry Abraham and Eugene Bloch using a vacuum tube during the World War I. So basically, a relaxation oscillator is a non-linear oscillator that has the ability to generate a non-sinusoidal periodic waveform at its output. And the waves can be triangular wave, square wave, etc. And they are also known as non-sinusoidal waveform generators. A relaxation oscillator operates in such a way that it generates oscillations by charging the capacitor and quickly discharging it after attaining a predetermined threshold value. So oscillators, now they are classified into two categories: linear oscillators for sinusoidal waveforms and relaxation oscillators for non-sinusoidal waveforms as written in the presentation. Now, a relaxation oscillator must provide a repetitive and periodic signal for non-sinusoidal waveforms like triangular, square, and rectangular waves at its output. The design of the relaxation oscillator must include nonlinear elements like the transistor, op-amp, and MOSFET, MOSFET, and energy storing devices like capacitor and inductor. To produce a cycle, the capacitor and inductor charge and discharge continuously, and the frequency of the cycle or period of oscillation depends on the time constant. So, if there is a capacitor which stores the energy supplied by the external source, then and releases the particular energy in another phase. So basically, at the time of charging of the capacitor, the bulb connected to the circuit does not get illuminated. But at the time of discharging of the capacitor, the bulb starts flashing for a time period determined by the RC time constant. This operating principle is adopted by the relaxation oscillator. Now, how does a relaxation oscillator work? The relaxation oscillator consists of energy storing devices like capacitor and inductor. These devices are charged by a source and discharged through a load. The shape of the output waveform of the relaxation oscillator depends on the time constant of the circuit, which is given by the equation. Now, we are going to understand the working of the relaxation oscillator with the help of an example. So consider that a capacitor is connected between a bulb and a battery. Now, this circuit can also be called as the flasher circuit or RC relaxation oscillator. A battery charges the capacitor through the resistor. During the charging of the capacitor, the bulb remains in off condition. When the capacitor reaches its threshold value, it discharges through the bulb. Thus, during discharging of the capacitor, the bulb is glowing. When the capacitor is discharged, it starts charging by the source again and the bulb remains off. So the process of charging and discharging of the capacitor is continuous and periodic. Um, so basically, at the time of charging of the capacitor, the bulb connected to the circuit does not get illuminated, but at the time of discharging of the capacitor, the bulb starts flashing for a time period determined by the RC time constant given by the equation. Now, the charging time of the capacitor determines the time constant, and the time constant depends on the value of resistor and capacitor of the for the RC circuit. Therefore, the flashing rate of the bulb decides the value of resistor and capacitor. And the waveforms, there can be different types of waveforms, which square waveform, triangular waveform, and they are basically periodic, as it is a periodic cycle. To control the output waveform, non-linear elements are used in the circuit. Now, if we consider the diagram of relaxation oscillator, so basically the relaxation oscillator consists of capacitors and resistors. And there are three types of circuit diagrams. One of the relaxation oscillator is op-amp relaxation oscillator. An op-amp relaxation oscillator is also known as an astable multivibrator. It is used to generate square waves. The circuit diagram of the op-amp relaxation oscillator is shown The circuit consists of capacitor, resistors, and an op amp. The non-inverting terminal of op amp is connected with an RC circuit. So the capacitor voltage VC is the same as the voltage at non-inverting terminal V minus of op amp. An inverting terminal is connected with the resistor. When the op amp is used with positive feedback, the circuit is known as Schmidt trigger. So in Schmidt trigger, there are two scales, which is UTP and LTP. UTP is upper trigger point and LTP is lower trigger point. So when V plus is greater than V minus, the output voltage is plus V volt, which is the UTP point, upper trigger point. And when V minus is greater than V plus, the output voltage is minus 12 volt, which is the lower trigger point, LTP. Now, for the initial condition at time t equal to 0, if we assume that the capacitor is fully discharged, so the voltage at the non-inverting terminal is V minus, which is equal to 0. And the voltage at the inverting terminals, V plus, is equal to beta V out. And in order to make the calculation easy, we consider the rest of the two resistors, R2 and R3, the values are same. So if beta is equal to 2 and beta V out is equal to 6 volt. So the capacitor will charge and discharge up to 6 volt. In this condition, V plus is greater than V minus. So output voltage V out is equal to plus 12 volt and the capacitor starts charging. When the capacitor voltage is greater than 6 volt, V minus is greater than V plus. Hence the output voltage changes to minus 12 volt. So in this case, basically when the initial condition when t was equal to 0, the non-inverting terminal B was equal to 0 and the voltage terminals B plus was equal to beta B out. And since we consider the value of the rest of the two resistors R2 and R3 are same, so we get the value of beta as 2 and beta V out as 6 volt. Now the capacitor, it charges and then it discharges up to, it reaches a maximum point and then it discharges up to 6 volt. Now in this condition, what happens is plus V is greater than minus V, and the output voltage is plus 12 volt, and the capacitor now starts charging. When the capacitor is greater than the capacitor voltage is greater than 6 volt, V minus is greater than V plus, obviously. So the output voltage changes to minus 12 volt. Now we're going to talk about UJT relaxation oscillator. So the UJT relaxation oscillator is composed of a uni-junction transistor and a capacitor, which gets charged through resistor R1 and gets discharged through the resistor R2. The externally supplied voltage to the circuit is VBB. So it provides a non-sinusoidal waveform at its output. When the interbase supply voltage VBB is supplied to the circuit, then the capacitor present in the circuit starts charging through resistor R1. At the time of charging of the capacitor, the voltage present across the capacitor shows an exponential increase until a peak voltage is achieved. This peak voltage is indicated as VP. Once the capacitor voltage reaches VP, the UJT present in the circuit gets on. And as the UJT turns on, the capacitor now starts discharging through the resistor R2 present in the circuit. So the discharging current flows through the resistor R2, generates a voltage spike. So this was UJT relaxation oscillator. Now, if we talk about the applications of UJT relaxation oscillator, they are used in function generators, electronic beepers, SMPS, inverters, blinkers, and voltage controlled oscillators. Other than that, these were the applications of UJT relaxation oscillator. Relaxation oscillators in general, they are used to produce low frequency signals for applications such as blinking lights and electronic beepers, and in voltage controlled oscillators, VCOs, inverters and switching power supplies, dual slope analog to digital converters and function generators. Now, if we talk about the advantages of relaxation oscillator, they have a constant frequency turning gain. Their phase can be read out continuously due to their triangular or sawtooth waveform. Triangular waveform is also known as sawtooth waveform. And these are the advantages of using relaxation oscillator. Now, if we talk about the disadvantages, so they are unstable, and for the good control features, it requires a complex circuitry. UJT relaxation oscillator can be used as a pulse generator when the voltage across the discharge resistor is used. So these are the disadvantages of using relaxation or oscillator. So this brings us to the end of our presentation. Thank you.